Okay, today we are going to prepare a certain experiment according to density, according to pressure, and other science items. First, we start from this one. As our target is improvisation, you see this one is a normal plastic glass. You can find anywhere in your store. So we have the straws. We may have even this, and we may have the water. If we pull the water in the glass and try to fill, up, and we cut our paper. And put what will happen, what's gonna happen. Wow, you see, wow, it can't fall down. Well, we can try this air pressure experiment. First, filling the water inside this glass, then put up a paper and try to put up on this glass and fill the water in this glass, then reverse our glass like this. I think everyone knows, like, when we hold this one, nothing will happen. Then you can put here. Okay. Then we can pull our paper. Oh my God, you can't pull because it's so wet. Okay. Oh my gosh. Oh my gosh. That is black. Okay, well, actually this experiment is so difficult to do, and see the paper wait before you bring out. Another is we have the water inside. We have to straw. We can cut in between so that you can get out. And this one, as long as it is. So let's try to put this one in the water and then blow up here up and see what happened. Let's see this small one. When we try to put the distance between and this straw, and we must sort the length one. Okay, the length one, you see. So we may try to pour out directly and easily, like this. Like this. We are going to see how we can suspend a kettle in the air. Here we have a whole kettle, and here we have a table. Here we have chopsticks, and here we have rubber band. So how can we suspend this one in the air, and what do we really want to show? As you can see, we can suspend this one, and you can feel the force on this arm. So if we try to cut one chopstick and touch on this long one, you see this is like a half of it, and we try to attach them with this rubber band, we can find something like this. Then this is our kettle. We can put this short on this short hand like this, and we can try to let the table handle it. Wow, it can be suspended. So why this is suspended? Notice that the mass of this, the weight of this kettle is under the table. So that's because the kettle center of gravity is directly below the support of chopstick, where the chopstick attached on this table. So here we did the center of gravity. Well, As we can see, we have this one's aluminum cup, like same like this. And if not possible, maybe difficult, we can remove this cover such that you can remain the original aluminum. We had the straw, plastic straw. We had the tissues, these ones. We had the balloon. Then, as we can see, the balloon and the straw, they can bend the water, as seen. They can attract the aluminum, the metal. So, what is the phenomena behind them? This is called electrostatics. What is the phenomena behind it? When we rub this straw with using this tissue, we are creating the charges. Now, as everything has all charges, negative as well as positive, when we rub this, the negative charges are produced and moved to outside this straw. While this outside the tissue, it is produced the positive ones. And when we put together a metal like this one here, a contact, it produces positive side outside to be attracted with these negative ones produced on this straw. That's why when we put this tissue near this one, instead of rolling towards this tissue, it goes another direction. That's why it has outside the positive charge, as well as here we have positive charges. This experiment shows that how we can grimp these grains of rice using this tube. So we can pour the rice in till it goes up. Okay, and you can put our chopstick inside and full of these grains of rice. Like this. Then maybe use this one to pack. And free again. And now we are ready to lift our chopstick without let down the tube. So let's try it. Okay, we can raise it like this. So we can lift chopstick together. So why? This is because the friction force between the rice and this chopstick makes this chopstick not to come over alone. So it gathers with this rice together. Here, testing a metal, we can use the spoon, any metal, or even the paper clip, or even this one, but we can first remove as aluminium metal. Now if we try to put on my tongue, I can taste nothing. But if we put together this and the taste, let's see. Oh wow, so bitter. It's so bitter. Now these ones are considered as the conductor, electrodes, and my saliva on my tongue is considered as electrolyte, liquid able to conduct electricity. Now this combination of the saliva and these metals as the two electrodes make a battery, and the current is considered as the bitter taste. So in that case, we can test the metals able to conduct the electricity. So let's try to cut this one. It is a milk bottle, and we can put inside a plastic glove and cover outside and try to bring out this glove. Okay, here we get. Okay, can try to bring out it. But it is so difficult. So difficult. Why it can't come easily? It is because the air inside this makeup between the groove and this cup is so tight, because here we covered. That's why from outside you can't pull out this groove. This experiment shows how we can lift our jar using our palm. As you see, if we try to lift this, it can't. What kind of thing or tree you can use to lift this one? Here we have hot water. We can pour the hot water in it and see. This is hot water. Can shake it. Oh, shit. Okay, let me try this one again. See, it's hot. And you pour it. See, it can stretch itself. See? And we left it. Yes. It can work. Can lift it. Now, what is the phenomena behind this one? See, at first time we have poured the hot water inside this one and pour out. In that case, the air inside was so hot. After instant, the vapor inside becomes so cool and becomes water, liquid. And then if the hotness becomes coldness, the pressure inside decreases. Then the pressure outside then increase. That's why it can swing this bottle inward, and the bottle will shrink my palm. This palm seems to be a good seal to the bottle here. So it seems like my palm is sucked into the bottle, but it's not. Instead, is the bottle which is strengthened and stretched to my palm. So here, it's the change in pressure which can act on this phenomenon. Like this, in that case, we will not use the palm, but maybe the okay now we use this one to close. Now let's see where the distance is. The distance is here. Still this up is long, so let's wait and see it will happen. Wow, it's still again stretching, 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 and I can see that even this one is going inside. And instead of this one, you can again even use an egg, a cooked egg here, but without shell. Well, okay, that's it.